you have x to the 8 over 9 equal to 2, then what is x? So to answer this, let's recall that we will need to pay attention to the numerator of the exponent here. The exponent has a numerator of an even number, like in even. So the numerator here is 8. So if the numerator is even, to solve for that, you have 8 over 9 equal to 2. You will have to multiply the exponent by the reciprocal of the power, which is 9 over 8. Your goal is to make the exponent equal to 1. So to do that, you will have to multiply it by its reciprocal. And you would need to do that on both sides of the equation to maintain equality. So you would do 9 over 8 here as well. Now, because the numerator here is even, then you would have to put plus or minus to the base. So that means x is equal to plus or minus 2 to the 9 over 8. Fill in the blanks. To solve for x to the 4th minus 17x squared plus 34 equal to 0, let u be equal to blank, and then write the equation in terms of u as. So now let's take a look at, or let's think about what our u would be so that this equation becomes a quadratic expression. Now, if you look at the middle term here, we have x squared, and the first term is x to the 4th. Notice that x to the 4th is just the square of x squared. So let's think of u, let u be equal to x squared. So if you do that, that x to the 4th, we know that x to the 4th, that means you square x squared, is just equal to u squared. So this means that this x to the 4th here will just be u squared, and then minus 17. Now that x squared is just u, and then plus 34 equal to 0. So this would be your quadratic expression. So your u is x squared, and you rewrite the equation in terms of u as u squared minus 17u plus 34. So let's take a look at this example here. Solve the radical equation and check all proposed solutions. And so I have copied over the question here. Now, to solve the radical equation, we would have to remove the square root sign here. And how would you do that? You can do that by squaring both sides of your equation. Okay, so you can raise both sides of your equation to 2. Then the square of the square root is just equal to the index, which is 2x plus 4. So the expression inside the square root. So when you square a square root, you essentially cancel the square root. So you will have 2x plus 4, no, not 4, 5. 2x plus 5 is equal to quantity x minus 5 squared. Now you expand that. How would you expand this? You will expand this using the formula. So if you remember, you can expand that by multiplying x minus 5 times x minus 5, and then use the FOIL method. So if you use the FOIL method, this will just be equal to x squared, and then FOIL stands for first, and then the outer. So that is negative 5x. And then the inner terms, you multiply them, minus 5x. and then the last terms, so plus 25. So that is equal to x squared minus 10x plus 25. Or you could also use the formula. You can follow the formula for a plus or minus b quantity squared. This becomes a trinomial, which is equal to the square of the first term. So the first term is a, you square that, and then you double the product of the two terms. So that's 2 times ab, and then the third term is the square of the last term. The third term would always be positive, and the middle term follows the sign of the binomial. So it's either plus if it's plus, and then minus if this one is minus. That would be the expansion here. So if you apply that to x minus 5 squared, that is equal to x squared minus, you multiply negative 5 and x, so negative 5x times 2 is negative 10x, plus you square the last term, which is 25. See, you got the same expression. All right, so going back to the problem, the right-hand side becomes x squared minus 10x plus 25. And then you solve for x. So to solve for x, we would solve the equation. We would put all the expressions on one side, and we want the other side to be 0. So we want always the leading term to be positive. So that means we need to move the 5 here to that side and the negative 2x to that side, so that we can have a 0 on this side of the equation. So x squared was not moved. You just have to copy that. And then negative 10x also is from this side. But then the 2x here from positive will become negative when moved to the other side. So that would be minus 2x. Then you copy the 25. Then you move 5. So from positive 5, it will become negative 5. So minus 5. Then you simplify your equation. So x squared minus 12x plus 20 equal to 0. Or you may write that as x squared minus 12x plus 20 equal to 0, because equation is symmetric or quality symmetric. So you could flip it. Then next is to factor. You factor this quadratic expression here. So you factor this into two binomials. So the first term in the factor are the factors of the first term here. So this is the opposite of FOIL. Then now you think of what to place here from the factors of 20. So think of factors of 20 such that the sum is equal to 12. So what are the factors of 20? 20 could be 10 times 2, right? Also 5 times 4. But 5 times 4, 5 and 4 will not sum up to 12. But it will be, if you add 5 and 4, it's equal to 9. But if you add 10 and 2, that's equal to 12. So that is the factors that we're looking for. So we have a 10 here and a 2. Now both of them will be negative because the middle term is negative. And then you can check if you have factored this correctly by doing the FOIL method. Or you can just check the inner and the outer terms. Multiply this, it's negative 2x, and that's negative 10x. If you add them, that would total to negative 12x. So now that we have the expression in factored form, then we can equate each factor to 0. Equate each factor to 0. And then solve for x. So if x minus 2 is 0, then x is equal to 2. If x minus 10 is 0, then x is equal to 10. Now we have two values of x here, but we're not sure if both of these values will satisfy the original equation. So thus, we need to check for the proposed solution. So these are just the proposed solution. These two are just the proposed solution. We need to check. And then when you check, you always have to use the original equation. So in this case, we would need to use 2x plus 5 and then x minus 5. And what you would do is you would plug in the value of x here to the original equation. So you would say if x is equal to 2, then the expression will be 2 times 2 plus 5. And is that equal to 2 minus 5? This is equal to 4 plus 5, and that's 9. But is that equal to negative 3? Is the square root of 9 equal to negative 3? The answer is no, because the square root of 9 is 3. So that is not equal to negative 3. So we know that x minus 2 is an extraneous solution. Or we call that extraneous root. Then you can also check for when the equation 2x plus 5 is equal to 10. So you say if x is equal to 10, so here you would want to check if x is equal to 10, this expression will be 2 times 10 plus 5 equal to 10 minus 5. Now 2 times 10 is 20 plus 5 is 25. So you have 25 equal to 5. Is the square root of 25 equal to 5? The answer is yes. So therefore, x equals 10 is the solution. Then you go back to the problem here, and then you would choose A, and then you would write the solution here, which are the number here. In this case, we got a 10. So you have 10. Oops, write that down. So we have 10. All right, and then you can check your answer. So make sure to also read annotations here. Sometimes you would ask to simplify your answer or write your answer in exact form. If it's in exact form, that means you have to write it in fraction form and you don't write it in decimal. So make sure to read the annotations here, to read the instructions on how you would input your answer. Okay, and then you check your work. Okay, so let's proceed to the next question. Solve the equations with rational exponents. All right, I have copied the equation here so we could work on the solution to this problem. So here we are given an expression with rational exponents and we want to get the value for x here. So to solve this, we would need to remove that exponent. We would need to remove the exponent here so we would be able to isolate x. So to do this, we will have to recall the very important concept that we have learned previously, such that if you have x to the n over m equal to c and you want to solve for x, you can solve this by raising both sides of your equation to the reciprocal of the power here, the reciprocal of that exponent. And also you need to pay attention to the numerator here. So if this is even, so if you have something of that form and n is even, So the exponent is even. Then x to the x is just equal to plus or minus c to the reciprocal of the exponent, m over n. And we will have to apply that to the given equation here. So to solve this, we will have x minus 3, that's the base, and that will be equal to plus or minus 49 to the 3 halves. Again, we put plus or minus because the numerator here is even. And then you can solve now. So notice that 49 is 7 squared. So you have plus or minus 7 squared raised to 3 halves. And then the 2 here will cancel. So that will be plus or minus 7 cubed, x minus 3. And then you expand. What is 7 cubed? So 7 cubed is 343. So you put plus or minus here. So you have x minus 3 equal to plus or minus 343. And then you could split that into 2 equations. So you have x minus 3 equal to positive 343. And the other one is x minus 3 equal to negative 343. And then you solve for each of the equation. So x here is equal to 346, and then x here is equal to negative 340. So those are the 2 values of x. Okay, so now let me offer you a different approach. So maybe you are a bit intimidated on how I solve this. Okay, so let's go back to that original equation and let's consider a different approach. So once you have your x minus 3 equal to plus or minus 49 to the 3 halves, you may alternatively do this. So remember, if you have a fractional exponent, that you could also write that in radical expression form. So recall that if you have x to the n over m, this is the same as the mth root of x to the n. So in this case, if you have 49 to the 3 halves, that is the same as 49 the square root of 49 cubed. And the square root of 49 cubed can also be written as square root of 49 quantity cubed. Then you would put the plus or minus here. Then you can plug that into your calculator. Square root of 49 is 7. So you will have plus or minus 7 raised to 3. So, and then you would end up with the same equation. So you can copy that over, x minus 3, x minus 3, x minus 3. So you have x minus 3 equal to plus or minus 343. And you would end up with the same answer. X is equal to 346 or x equal to negative 340. Now let's proceed to the next question here. Now let's consider the following question. Solve the following equation by making an appropriate substitution. Now when considering what appropriate substitution to use, you can consider the equation, or you can examine the equation and notice that this one is raised to negative 2 and that is raised to negative 1. And it has 3 terms, so it feels like it resembles a quadratic equation. So now, if you could just let, say for instance, this x to the negative 1 here, be a different variable, say u, then you can write the equation as the third or the middle term will be negative 3u minus 4. Now what about the first term? So notice that if you square x to the negative 1, that is the same as x to the negative 2. So that means if I square x to the negative 1, I can also square u here. So x to the negative 2 is just u squared. So therefore, the first term here will just be u squared. And then you copy 0 to the right side of the equation. So now you are just going to solve for this quadratic expression here. So then you can proceed by solving the quadratic equation here by factoring. So you could factor this into u, so you have a binomial. U would be the first term. Then you think of factors of 4 so that the difference is negative 3. So what are the different factors of 4? You can think of 2 and 2, but if you subtract them, it's not going to give you 3. But if you have, what's the other factor? 1 and 4. If you subtract 1 and 4, you get a 3. So those are the factors we're looking for. So you can do 4 here and 1. Now you decide which one gets the negative sign. So again, how do you come up with a negative 3? You can obtain that if this is negative 4. So if that is negative 4, so that would be minus, and that would be positive 1. Okay. Now, after you factor this, you can equate each factor to 0. So you have u minus 4 equal to 0, or u plus 1 equal to 0. And then you solve for u. U is equal to 4. And if u plus 1 is 0, u is equal to negative 1. Now you don't stop there, because these are the values of u. And what you're looking for are the values of x. So then you substitute it back to your u. Now you let u be equal to x to the negative 1. So you will have x to the negative 1 equal to 4. And then replace the u here by x to the negative 1 equal to negative 1. Now what do you mean by x to the negative 1? X to the negative 1 is the same as 1 over x. That's laws of exponents. So you have 4. 1 over x equal to 4. Then to solve this, you can cross multiply. You can have 1 equal to 4x, and then divide both sides by 4. So x is equal to 1/4. Now here, you will have 1 over x. X to the negative 1 is 1 over x equal to negative 1. And so x is equal to negative 1. We have cross multiply, so you have 1 equal to negative x. Divide both sides by negative 1. So therefore x is equal to negative 1. Those are the two values of x. Now the only time you would exclude a value for x in the solution is if when this one of the terms becomes undefined. Now in this case, this will only be undefined when x is equal to 0, because x to the negative 1 is 1 over x, and so that would only be undefined when x is equal to 0. Now since these two values here are not equal to 0, then those two values are solutions to the quadratic or to the expression here. So going back to the question here, you would type in x to the negative 1 here as your u. So u would be x to the negative 1. And then you write the quadratic equation here that is in terms of u. And then you write the solution here. Okay, let's proceed to the next question. That's just similar to the question in number 6, so I won't do that. Let's have another one. Here we have a conceptual question. Select the answers that best complete the given statements. Any set of ordered pairs is called so look at the choices here. Is it called a function, a variable, a range, domain, or relation? The answer is relation. So it's a relationship between the x coordinate and the y coordinate. So the relationship is defined by some expression. And you know that not all relationships are functions. Okay, but every function is a relationship. So it's a relation. And then so here it's a relation. And then the first set, the set of all first components of the ordered pairs is called we call that the domain. And then the second components, the collection of all the second components of the ordered pairs is called a range. So the second component is called a range. Okay, now let's proceed to the next one. Okay. Determine if the following statement is true or false. Okay, so I would leave this to you, like all the conceptual question. I want you to figure those out. And let's look at some other problems. So those are all conceptual questions as well. But, you know, here, it says here, if you have a function x squared minus 5x plus 4, it is possible to also find x plus 5 by replacing each occurrence of x in the variable here by the expression here, by x plus 5. So again, if you are given f of x and you want to find f of x plus 5, you can do that by replacing the x here in your f of x by x plus 5. So it's like evaluating the function at x plus 5. All right, now here, determine whether the relation is a function and then give the domain and range of the relation. So look at the set of ordered pairs here. Is this a function or not? So if you are given a set of ordered pairs and you want to know whether it is a function or not, you examine the x values and the y values. So you look at the x values here, and then you don't want one x to be paired to different y values. In that case, that will not be a function, because you will, if you actually graph that, so if you have one x, say for instance, in that case, x equals 3, it is paired to two y values, 1 and 9. So that means that you may have like a graph that would look like that. And that is not a function because it doesn't satisfy the vertical line test. So when you say vertical line test, that means that if you create a vertical line on the graph of your function, or the graph of on the graph, it would only cross the graph at one point. So if it crosses at two different points, then it is not a function, but rather just a relation. So in this case, because we found an x value that is paired to two different y values, okay, and an x here paired to two different y values, then this is not a function. Now, what about the domain? So what's the domain? When you say domain, it is the set of all x values. So what are the x values here? You have 3, 3, 6, 6. Now, in that case, you would only need to write it once. So you write down 3 and 6. So since 3 and 6 are repeated, you don't need to write 3 twice and 6 twice. You just need to write it once. And then for the range, the same thing. You don't need to write them once if they occur. You don't need to write them more than once if they occur several times. So 1 occurs twice, you only need to write it once. And then 9 also occurs twice, but you only need to write it once. So the range would be the set containing 1, 9. The domain is the set containing 3, 6. Again, domain, x values. Range, y values. Next question. Determine whether the equation defines y as a function of x. So if you are given an equation and you are asked to determine whether it is a function or not, all you need to do is think of or assign a value for x. You assign a value for x and then you solve for y. When you assign a value for x and you solve for y and you get 2 different y values, then it is not a function. But if when you assign a value for x and you get just 1 value of y, then it is a function. And generally, if you have something like this and they're raised to power, you just have to look at the power of your y variable. If it is raised to an odd power, it is a function. If it is raised to an even power, it is not a function. Okay, so in this case, this one is raised to an odd power. The y is raised to an odd power. So that is a function. The equation defines y as a function of x. So let's check. There we go. Let's have another example. Now here, this is different because then you have here a product. You have x, y, and you also have y here. Okay, so I would say in this case, you can solve for y in terms of x, or you can plug in y and you can plug in a value for x and try to solve for y. All right, so let's try those options. So here, we know we could isolate that y. So you have y, x plus 5 is equal to 5. So therefore, you can divide both sides by x plus 5. So y is equal to 5 over x plus 5. Notice that if you plug in one value for x, you will just get one y value. So this is a function. So let's go ahead and check. We click on yes, and then you check. All right, we got the answer right.